because this is to get you ready for the test. Okay? And so if you cheat, it's not worth a whole lot compared to the test. So it's a self-assessing tool. So you're assessing yourself, which is one of the best ways of learning, by the way. If you can go through the mistake and see it for yourself, as opposed to just getting it handed back to you and it's like, oh, I got it wrong. Okay, big deal, right? No, it's like live, immediate feedback, so you know where you're at. All right. So here we go. Canada's Centennial Maple Leaf is made up of 11 equilateral triangles. That should right away stick out to you, right? Equilateral, all sides are the same. All angles are 60, right? Two things given to you there. And what's the measure of angle A? So since these are all equilateral, right, we know that all three sides are the same, so it's 60 all around. So it's 60 degrees, just like that. If you got that, you got a mark there. State the measure of angle B. Now here you have to be careful. And I'm going to highlight that in pink here. There's a straight line going here, and it's being cut by this side. So these two must add up to 180. Okay? Every time you have a straight line, it's 180, right? If anything cuts it, right, and you know this side, you can just find this one by subtracting it from 180. So this is 120 in there. So you can just go 180 minus 60 if you wanted to show work, but make sure you clearly indicate your answer. Okay. State what type of quadrilateral is formed by combining triangles X and Y. So you should be looking at these two combined. And what do we know? Well, look at this shape. All three sides here are the same. So is this triangle. So if you copy this, if you combine them, you know that all four sides are the same. It looks like a diamond, right? It's not, it's definitely not a square. It is a rhombus. Okay, so that's the only answer I'm going to accept here, because you have to be as specific as possible, right? All sides are the same. We're not, and we know that this is not a square. You know why? Because this is 60 and this is 60, so this is 120 degrees here, right? So these are 120 each, and at the tops they're 60, right? So right away you know that it's not going to be a square. You would have to look for the 90 if you wanted that. So that's a mark. So 1, 2, 3 so far. So question one is out of 3. Make sure you label that. And then moving on. This is actually something. This is what this unit is all about. Like triangles, quadrilaterals combined, maybe even polygons later. Do you know how to classify them, right? And moving on. Could you have said a kite? Kite and square are not acceptable, right? Like it has to be very specific to this shape, right? So this fulfills all the requirements for a rhombus. Number 2, okay, squares and parallelograms are geometric figures using properties of polygons, right? Explain why a square is a parallelogram. What does the square have that is also true for a parallelogram? Well, let's look at, because this is a learning tool as well. A parallelogram looks like this, a square looks like this. What do they both have in common? Well, a parallelogram tells us that these two lines are parallel to each other and these two lines are parallel to each other. That is also true for a square. So it has two pairs of parallel sides. It has two pairs of parallel sides. So That's what I'm going to go with. Okay, why is a square a parallelogram? Because a square also has two pairs of parallel sides. You can use that symbol for parallel, referring to parallel sides. Okay, so that's why a square is also a parallelogram. So you got that. Explain why parallelogram is not always a square. So why is a parallelogram not always a square? Because a parallelogram does not have to have 90-degree angles. Okay, all four corners. That would be a 1. A parallelogram does not always have 90-degree angles. That'd be 1. Could you think of another one? Parallelogram doesn't have to have all four sides equal, right? So a parallelogram, there could be a parallelogram that does not have all four sides being equal. So that'd be another reason why it isn't always a square. So you can use those strategies to come up with a reason why it's not. So when it says explain, you have to expand a little bit. If it says state, then you just say, a short, like for example, state an advantage of buying a new car. It's safer. Done. No explanation needed. Pedro's building a triangular roof for a house. He would like to build as steep as possible so snow does not accumulate on the roof. State whether Pedro's roof, so there it is, that word, state, right, should be equilateral or isosceles. Now, we talked about that yesterday, and it's isosceles that wins, right? Because isosceles allows you to have a really skinny, right, a really small angle here, because isosceles just has to have both of these being the same. So then isosceles is the one. Justify answer from part A. Because isosceles triangle can have a small angle at the top and still have the other two equal. Right? And an equilateral does not allow you to change that angle at all. It's 60, it's fixed, right? So there it is. So you got 1 mark for just stating, and then 1 mark for explaining it, and the explanation should be, if it's not quite right, nowadays we're allowed, if I read it and I'm like, okay, you kind of have a point, but you're not quite finished your point, I would take off half a mark. If it's like it used to be all or nothing. Now we're allowed to, because teachers complain saying, because according to the province, we would have to give you 0 sometimes if you didn't make your point. Teachers are saying, well, I know my student. I know that he or she meant to say this. It just didn't come across on that paper. So that's where we're allowed to give at least half a mark these days. All right. Backside. Oh, let me just, okay, question 1 is out of 3. Okay, so make sure you put a mark down out of 3 there. 1 for each question. Question 2 is out of 2. Question 3 is out of 2. Okay, so far we are at 2, 4, and 7. This page is 7. Okay. Backside. A kite is a type of polygon state two properties of this polygon. Property 1, right, it has two pairs. This is where your study sheet comes in with the stuff I give you on page 190. Two pairs of congruent sides. So because we know that in a kite, these two are the same and these two are the same. So that's the first one I would do. You can say that the diagonals meet at a 90. Or if you want it more elegant, right? Diagonals are perpendicular. Either one of them they both are saying that. I don't mind you using your own words. What else could you have said if there's a third property here, right? That there's one pair of opposite equal angles, right? Of congruent or equal angles. Right? This is the only pair that is equal in this thing. These two are not. And the easiest one of all, I like to give you options. Sum of angles is 360, right? Any quadrilateral, any four-sided shape has a sum of angles that is 360. But that one is a little bit vague. It's not specific. Oh, it is still part of this. Sorry, it is true. But I would stick with these ones here. These are the best ones. Because depending on how it's worded, it might be very specific to the kite that they want. Okay, so this would be worth 1 mark for each. Okay, 1 mark for each. So 4 is out of 2. And question 5. We did something like this, okay? If you followed the lessons, right? This was done yesterday, something like this. A student is solving a math question involving a 100-meter truss bridge. The bridge is made of 7 equilateral. There's that word again, right? That's your, if it's isosceles or equilateral, it's your friend, right? As shown in the diagram below. Sketch one of the bridge's triangles and state all side and angle measures. Let me just focus here because it seems to be out of focus. There. So you sketch one, right? You take one of these out. Because it's equilateral, we know that they're all 60. There. Okay, that's for sure. That's 1 mark. What about the side length? Well, we know that all of these stretches here measure the same, right? Because they're all equilateral. And so you just go 100, right? 100 divided by 4, and that's 25 meters. Sorry, 25 meters. So this would be 25 meters, 25 meters, 25 meters. Okay, so 1 mark for angles, 1 mark for side lengths. Okay, so you get 1 for each. Six, that one was probably a little tougher. Okay, and by the way, I'm recording this one because it serves as a review. Okay, so I'm going to leave that up. Consider the following isosceles trapezoid. So that you should recognize that. Okay. Again, go to page 190. If you don't have that, get your buddy to send you a picture of page 190, or go back to the notes, okay, where we did this. Calculate the value of the indicated angles or sides. Because it's an isosceles, we know that the base angles are the same. So right away, all you need to do is to state that that's 70. Okay, that gets you 1 mark. Why? We know that the base angles are the same and these two sides are the same also. So that's 2.5 meters. So boom, you get 1 mark there, 1 mark there. Easiest 2 marks you can catch if you know what you're doing, right? Now find the area of this trapezoid. I gave you the formula of it. I know I didn't do this as an example, right? I never did I don't think I did the area of a trapezoid. So we'll call this a bonus. You get a maximum of +1 though for bonus if you get this right. So basically the formula talks about this being A, this being B, and this being the height. So A plus B times height divided by 2, right? That's what 1/2 does. If you multiply something by half, you're actually dividing the whole thing by 2. Okay, so we know A, we know B, we don't know the height of this thing. Okay, so on the side here, you know this is 70, this is a right angle because the height always makes a 90 with the ground. So this is my height, this is 2.5. So I have a pair, right? So sine of 90 over 2.5 is equal to sine of 70 over h. Copy this down at least so you know how to do it, okay? H is going to be 2.5 times sine of 70 divided by sine of 90, which we all know is 1, okay, by now. So H gives you 2. No, I should calculate it because I used Pythagorean theorem there. There's another way of doing this. So if somebody else used the Pythagorean theorem, you are okay to do that. We got 2.34. And we are meters, right? So this I would give you a half mark right there if you find the height. If you use Pythagorean theorem, you get 2.29. So I'll also give you that if you use that. So the area now is going to be A, which is the top, plus the bottom, divided by 2, and all of that times the height, which is now 2.34. Area is, this gives you 10 times 2.34 divided by 2. And that's 11.7 meters squared. So if you have this or something close to it, if you use Pythagorean theorem, here it is, it's 11.45. If you use Pythagorean theorem, because there's a way to cut this, and then if you go 6 minus 4, that's 2. You divide that, the difference of 2 by 2, and then you find that this little sliver is 1 here. And then use Pythagoras to find your height. So if you did that, and it's 11.45 square meters. So you get a bonus of 1 if you got B right. So let's go back. 6A is 2 marks. Okay. 5 is also worth 2 marks. 1 for the angles, 1 for the side lengths. And a question 4 is worth 2 marks. So this page is 2, 4, 6 technically without the bonus. So this page is at a 6. So what is our total? 7 and 6, that's 13. It's out of 13. So we're gonna scratch this for now and just make it out of 13. And possibly you can score 14 out of 13 if you get that bonus right. Okay, so at this point,